Hello everyone, I am going to explain question number 4 of exercise 7.4 from class 12. So in this exercise and in this question we have to find out dy over dx if x and y are given in terms of t. So we'll start. First we wrote here x. Now since we have to find out dy over dx means we have to differentiate them, but since x is in terms of t, so you can't differentiate it in directly with y or like that. So first differentiate the x with respect to t. So when you will differentiate, here you will obtain dx over dt, and here again we have to differentiate, but it is in the form of fraction, and you know when we differentiate fraction it's going to be like this: denominator square, the denominator, numerator differentiation, then numerator as it is, and then denominator differentiation. So we will follow this rule to differentiate this fraction. So in down we have to do denominator square, that's why square of this. Now here denominator, first you have to keep the denominator as it is. You have to start from the differentiating the numerator. So differentiate the numerator here, that's why this symbol came, derivative symbol came here. Then keep the numerator as it is and differentiate the denominator. Now since denominator is having root, so I wrote it in the power form so that easily we can differentiate. Now just see the next step. In next step, down when we do the square, this root and square will remove, so only cos 2t will come, and here this root cos 2t as it is. And when we differentiate here, you have to use x to the power n formula, that is n x n minus 1. So what is n here? 3, that's why 3, then x n minus 1. So you have to do n minus 1. N minus 1 means power minus 1. So here power is 3. So 3 minus 1 is 2. Then this x means sin t as it is. But it's not x, it's a ratio, trigonometric ratio. So you have to apply the chain rule. You have to differentiate the sin t again. So when we differentiate the sin t because of the chain rule, we will get here cos t. So this is the differentiation of sin cube t. That is this one. That is 3 sin square t multiplied by cos t. So how we obtain this? Because of xn formula, that is n x n minus 1. Then because of chain rule, when we differentiated sin t, we obtain the cos t. Now this sin cube t as it is. Now we have to differentiate it. So again it will behave as x to the power n, that is n x n minus 1. That's why. So what is n here? 1 upon 2. So 1 upon 2. Now when you will do n minus 1, so half minus 1. So when you will do half minus 1, what you will obtain? Minus half. And minus half means power is negative, so it will move to the denominator, and because of half it's going to be root. Means it is, this is this half, and this is your n x n minus 1. Because n, that is half, n minus 1 you will get minus half, and because of minus half it again came in the denominator. Now you have to apply the chain rule. So you have to differentiate the cos 2t. So when you will differentiate the cos 2t, you will obtain the sin 2t. Again you have to apply the chain rule to the 2t also. So when you will apply the chain rule to the 2t, you have to differentiate the 2t. So you will get 2 into 1. So that 1 I not wrong. Means when you will differentiate it, you have to use the formula n x n minus 1 and then apply the chain rule 2 times. First differentiate cos 2t, and then again differentiate the 2t also. So you will obtain this. Now in next step, here we will take the LCM. So when you will take the LCM, we don't have any denominator, so write here 1, take the LCM. So when you will take LCM, you will obtain the LCM as root cos 2t, and here when you will do the cross multiply, it will multiply by this and root symbol will remove, and the LCM of this term and this term is cos 2t, that LCM will shift down, that's why it shifted down. And here these two terms I wrote as it is, and when you will multiply, cross multiply, because of LCM you will get cos 2t, and cos 2t you have to multiply, so you will get here root will remove, only cos 2t. And because the LCM we took is root cos 2t, so you have to multiply this term by 1. Now before that this 2 and 2 got cancelled, and because of minus and minus it becomes positive. So multiply it by 1, you will obtain this. So this is simply I took the LCM, and LCM are shifted in the denominator. Now Here just see what things you can take common. So you can see sin square t you can take common. So take sin square t common. After common we will obtain this. Now this sin 2t just write down as 2 multiplied by sin t and cos t by sin 2 theta formula. Again I am repeating, sin 2t, use the formula of sin 2 theta, that is 2 sin theta cos theta. You will obtain 2 sin t cos t. Now from here sin square went outside. So what is remain from here? Sin t. So write here sin t. Now again you can see this cos t and this cos t is common. So take cos t outside, and in denominator, students, here power is 1 and here power is, because if you write it in power form you will get half. So 1 and half you will add, so you will obtain 3 by 2. And in this side, because cos t went outside, so 2 cos t, and here cos t went outside, so 2 sin square t. So keep this as it is. Now we will move to the y. So y is this. You have to differentiate. Again use the fraction formula. So here when we use the fraction formula, denominator square, the denominator as it is, numerator differentiation, the numerator as it is, denominator differentiation. So when you will differentiate, you have to use xn formula, that is n x n minus 1, and then use the chain rule. That will give you 3 cos square t, that is n x n minus 1. Then chain rule, cos t you have to differentiate, so you will get minus sin t. Here again you have to use the chain rule, x to the power n formula, that is n x n minus 1. So when you will do it, you will get half, then x minus 1. So when you will do n minus 1, you will get half minus 1 is minus half. So what you will obtain? Its power is going to be minus half. So minus half, because you are getting minus, so it will shift in denominator, and because of half, both symbol will come. Then apply the chain rule. So you have to differentiate cos t and again 2t. So cos t differentiation is sin 2t minus sin 2t, and 2t's differentiation is only 2. So this 2 and 2 will remove, and this minus and minus sign become positive. Now take the LCM and shift the LCM down, that will give you this step. Now from here take cos square t common, that will give you this step. Here again sin 2t you just change as 2 sin t cos t because of sin 2 theta formula. Now here what you will find, the sin t is again common. So take sin t common, you will get this step. Now finally, since we want dy over dx, so divide equation 2 by equation 1. So when you will divide, you will get this. This is your dy over dt, and this is your reciprocal of dx over dt. So you can see cos 2t and cos 2t are same. So they will remove, cancel each other, and here also they will cancel. And now in this in the bracket, just see in the bracket, 2 cos square t formula I used, 1 plus cos 2t, and here 2 sin square t formula I used, that is 1 minus cos 2t. So from which formula I am using it? From formula of cos 2 theta, that is cos square theta minus sin square theta. So you just learn it. It's a standard formula of cos 2t and sin 2 sin square t. From this we can get this easily. So I replaced from it. Now this and this can subtract. So subtract them. After subtraction you will obtain this. And here you, after cancellation, you will get cos t and sin t, that is cot t. So the first part of question number 4 is completed. We will move to the second part of question number 4. Here x is this and y is this. Again find out dx over dt, that will give you this. So this a is outside, so it will behave as coefficient. So a is coefficient. Differentiate cos t, and this also. So cos t differentiation is minus sin t, and log 10 t upon 2. So log x formula is what? 1 upon x. So from there 1 upon 10 t upon 2, then apply the chain rule. So you have to differentiate the 10 t upon 2 also. So 10's differentiation is sec square theta, that's why, and t upon 2 also differentiate. So it's going to be half multiplied by 1. So I applied the chain rule, students. And so in short, just do, because we are doing the exercise 7.4. So each and every step if we do is going to be very long. So in short, you have to now start to do. So how we differentiated? First we differentiated log, then we differentiated 10, then we differentiated t upon 2. So it came like this. Now here 10 t upon 2 just write as sin upon cos, cos upon sin, and sec you just write as reciprocal of it, cancel it, you will obtain it like this. And carefully when you will observe, it is in the form of 2 sin theta cos theta, that is sin 2 theta formula because of it. 2 and 2 will remove, so you will obtain here only sin t. Take the LCM, you will get sin square t minus sin square t plus 1, that is cos square t. So this is your dx over dt. Now we will start from y. Y is a sin t, differentiate it, you will get a cos t. Divide equation 2 by equation 1. So you will obtain sin t upon cos t, that is tan t. Hence this question number 4 is completed. So I hope question number 4 is clear. Nothing is there. If you are getting your x and y as a fraction, use the fraction formula and then take care always of the chain rule. If your function is not in the simplest form, then apply the chain rule until you reach to the innermost function and take care of the formulas. Easily you can get these answers. Thank you.